The sheer vastness of the universe is utterly staggering, beyond any description we can muster. Yet when we gaze upon the breathtaking deep-field images captured by space telescopes, like Hubble and the James Webb Telescope, our perception of the cosmos undergoes a profound transformation. Images such as this reveal thousands of galaxies, helping us to begin comprehending that the Milky Way is merely one among countless galaxies. What's truly awe-inspiring is when we realise that the area of the sky we're observing is no larger than a grain of sand held at arm's length. It is then that the incomprehensible enormity of the universe truly hits home. We come to the realisation that our home planet Earth, our entire solar system, and even the Milky Way galaxy are specks within the cosmic expanse, and yet only 100 years ago the prevailing view confines the universe to within the boundaries of the Milky Way, considering it a static, unchanging entity. This narrow view of the universe, though, was shattered in a few short years during the 1920s, when Edwin Hubble made a series of discoveries that shifted our perspective of the cosmos. So join me, the Cosmic Skipper, as we delve into how Hubble expanded our view of the universe, and how the James Webb Space Telescope and Hubble telescopes have opened our eyes to the majesty within it. Thanks to the remarkable Hubble and James Webb Space Telescopes, our exploration of the universe has taken a quantum leap. We can now cast our gaze in any direction and see the splendour of distant galaxies. For instance, we can observe the majesty of the Sombrero Galaxy, which lies 31 million light-years away, or witness the awe-inspiring collision of the antenna galaxies, unfolding 45 million light-years from Earth. We also had images of the Andromeda Galaxy, which are crystal clear and sharp and are a far cry from the images available in Hubble's day, where astronomers speculated that these objects were star-forming nebula regions of space within the Milky Way. So when Edwin Hubble peered through the telescope from the Mount Wilson Observatory in California during the early 1920s, the prevailing belief was that the Milky Way spanned 100,000 to 300,000 light-years across and encompassed the entirety of the universe, with Andromeda being part of the Milky Way. This perspective was about to change as Hubble was looking at a modest star residing in the Andromeda Nebula named V1, or Variable 1. V1 belonged to a unique class of star known as Cepheid Variable Stars, and Hubble was putting to practical use the pioneering groundwork laid out by Henrietta Leavitt. Leavitt, a decade earlier, had made a remarkable connection while studying these stars. She found that they exhibited periodic fluctuations in brightness, and she correlated the period of these fluctuations to luminosity. In simpler terms, the faster they fluctuated, the naturally brighter they were. This newfound insight gave astronomers the ability to determine a star's inherent brightness based on its luminosity period, and by comparing this inherent brightness to its observed apparent brightness, they were able to work out the star's distance from Earth. Equipped with this knowledge and focusing on star V1 in Andromeda, Hubble calculated its distance from Earth, which at a staggering 900,000 light-years was well beyond the known 300,000 light-year span of the Milky Way. This remarkable discovery sparked a profound shift in our cosmic perspective, as it revealed an awe-inspiring reality. The universe had countless other galaxies, each housing stars, planets and celestial wonders, extended far beyond the boundaries of our own Milky Way. However, Hubble didn't stop there, as he turned his attention to the light coming from these distant galaxies and made a discovery that provided strong evidence for an expanding universe. His observations noted that light from distant galaxies was consistently appearing redder in colour, a phenomenon known as redshift. Hubble reasoned for this to be happening that these galaxies must be moving away from us. To help understand this, think of the universe as an inflating balloon. As the balloon inflates, 2 points on its surface would move away from each other. If light were travelling between these 2 points, the expanding balloon would stretch the wavelength of this light, making it longer, and the light that has a longer wavelength appears redder in colour, just as Hubble had observed. Hubble, in a few short years, confirmed the existence of galaxies beyond our Milky Way and expanded our understanding of the universe. Over the following decades, his work contributed to the development and acceptance of the Big Bang theory. According to this theory, the universe originated from a singularity around 13.8 billion years ago, has been expanding ever since, and the observable universe is estimated to have a radius of 46.5 billion years. However, Hubble was limited by the telescopes of the day, and so his observations were limited to the local group of galaxies, such as the Triangulum galaxy at a distance of 2.73 million light-years away, and the Andromeda galaxy at 2.5 million light-years away. Beyond this, he would not have been able to see many other galaxies, but when his namesake was launched in 1990, it was like a cosmic light switch had been flicked, and for the first time Hubble could see the sheer vastness of the universe. Deep-field images that show a universe where galaxies with high redshift values such as GNZ11 and formed a mere 400 million years after the Big Bang and now 32 billion light-years from us can be seen. We now have the James Webb Space Telescope peering even further back in time, where galaxies such as Glass Z12 are seen shining just 350 million years after the Big Bang, and is now 33 billion light-years from Earth. It's just mind-blowing that all this can be seen in a part of the sky the size of a grain of sand, and it makes you wonder what else is out there waiting to be discovered.